Fractions, exponents, and percentages. So the calculator that's recommended is a Texas Instrument TI 30X2S. Any calculator will do really as long as you have the exponent functions that are needed for the course and parentheses functions. You also need to be able to make a number negative. So these basic functions here, you see the parentheses, the negative, the little caret key for exponents, and so forth. So this is the calculator that I have and that I use. I recommend that you get a similar calculator. The use of AI or the internet to solve any problems in this class is strictly prohibited. The goal of this is to get you to be able to solve these mathematical problems on your own, so that if you're working at a benchtop in a hospital laboratory someday, you are able to calculate these by hand and perform the dilutions and all the laboratory math that you need to perform. Additionally, the qualifying exam for the ASCP exam requires you to be able to calculate out these problems. And the calculator that they provide you on screen has similar functions to this calculator that you're seeing here. It just has the ones that you absolutely need to be able to solve the problem. So you're not able to use the internet or AI on that qualifying exam. If you are not able to calculate out the math using just a calculator, pencil, paper, you won't be able to be successful on that qualifying exam. So it's really important that you actually do the work yourself, learn how to do the steps now so that you don't hurt yourself later on. If you have any questions about any of this content, please feel free to reach out. I'm happy to help. We also have tutoring services that are able to help with the math portion. But please be proactive about your education in this course, because this will definitely come back repeatedly throughout your program of study, and that qualifying exam, you have no option for AI on that. So you really do need to know how to do these processes. Now, we're going to go back to fractions, and fractions are very basic. I'm not going to spend a lot of time on basic math. If you do need additional review on math, I can definitely find some supplemental videos for you. Just send me an email and reach out, and I'm happy to locate those resources for you. But I'm just going to talk briefly about fractions. So fractions, there's a numerator, the top part, and the denominator, the bottom part. The top part is the number of parts we have, and the bottom part is the total parts in whole. So 2/5 means that we would have 2 out of the 5 total items. Functionally, this is a division problem. So convert these fractions to a decimal. So I am going to take out my calculator now and just do this division. You can go ahead and pause the video and do these division problems. Write out your answer, and then when you unpause, I will go through these. All right, so 4/5 is just 4 divided by 5. We have 0.8. 2/5, 2 divided by 5. We have 0.4. 6/10, 6 divided by 10 is 0.6. 1/3, 1 divided by 3 is 0.333, and that just goes on. Exponents. So when you see an exponent, what that actually means is that you have taken the number and multiplied it by itself that many times. Exponents are going to come in handy and become really useful for us when we start calculating dilutions and advanced like solution type problems. So it's important you know and understand what an exponent is. So if we were to convert these numbers to exponential form, they're all the same number. And when you multiply a number by itself, you just add how many times you've multiplied it by itself. So in exponential form, this is 1, 2, 3, 4, 5. So 8 to the 5th. This is 267 to the 2nd because we've multiplied it by itself. And then we have 1, 2, 3, 4, 5, 6. So this is 1 to the 6th. and 85. 85 is just 85, and there's only one of them. So now when it wants us to find the value, this means that we would take 2 times 2 times 2, that's 5 times of that. A faster way to do this is on our calculator, and you are able to use a calculator on the qualifying exam. It is an on-screen calculator that they provide to you, but it has the exponent function. So to put this into the calculator, you would do 2 and then the little caret key, 5. So 2 to the 5th is 32. Ten to the 3rd, 1,000. 16 to the 1 is just 16, and 3 to the 4, 81. Order of operations. So the order of operations is the order that you should complete mathematical problems in. Now, we're going to get into some basic algebra, but I just wanted to mention that this x is not an x, it's actually a multiplication sign. So when we go through these problems, it's just important to remember that that's multiplying. We're not in the algebra stuff yet. So first, you would look for any problems with parentheses. So there's no parentheses in this problem, so then we're going to look for exponents. Well, we do have an exponent, and here's our first exponent here. So we have 3 squared. 3 squared is 9. So we're going to do this exponent. We're going to put a 9, and then to make things clear and keep everything in order, I like to just rewrite the rest of the problem once I've solved a portion of it. Plus 6 minus 2 times 7. Now the next thing that we have to do is multiplication or division. So the first time we have multiplication or division is actually here, and that's 2 times 7. So 2 times 7 is 14. So what we're going to do here is rewrite the 9 plus the 6 minus 14. Now we can tackle the addition and subtraction. So 9 plus 6 minus 14, so that's 15 minus 14, we get 1. So now that I've gone through one, I'd like you to pause the video and attempt to solve this one. When you unpause, I'll solve it for everyone. Okay, so exponents come first. So in this problem, we're going to tackle this portion. So we have 7 times 4 to the 3rd is going to be 64. Minus 6 divided by 2. So we looked at the parentheses. We're trying to figure out what to do in the parentheses. We have to completely solve the inside of the parentheses before we can tackle the outside of the parentheses. So we do have to solve this before we can go on. Even though it's a subtraction problem, it's inside the parentheses. So the parentheses trumps the fact that it's a subtraction problem. So we're going to work on this one next. 64 minus 6 is 58. So we're going to do 7 times 58 divided by 2. And then we're just going to go from left to right. Since this is a multiplication division, this is also a multiplication division, we can just go left to right. So 7, I'm going to do this in my calculator, 7 times 58 divided by 2, 203. So one thing I am going to caution you is don't trust your math. If you have a calculator, use it. So I always double calculate every answer that I put out there, because if you calculate something wrong, you could potentially be diluting a solution incorrectly in the lab, which could lead to bad lab results. And if you calculate something incorrectly and you create a solution based on your faulty calculations, then you have now messed up the entire system for every test that comes after that. So it's extremely important that you double check your calculations. All right, go ahead and pause the video, work through this one, and then when you unpause, I'll solve it. Okay, so we've got parentheses here. So we're going to tackle the exponent first in the parentheses, so that's this portion here. So 5 squared is 25. So I just like to rewrite what I'm doing and keep track of my steps. 3 times 7 plus 25. Now we still have to solve what's in the parentheses to eliminate the parentheses. So we're going to tackle this next. So that becomes 124 minus 3 times 7 plus 25, 32. So now we're going to do this multiplication problem. 3 times 32, 96. Now we're going to do the final problem here. And we get 28. So solving this one without a calculator. I just want to talk briefly about this one because this one is something that you can just do and keep in your mind, and this is going to help you save time on that qualifying exam or when you're doing math calculations. Now you can definitely go ahead and calculate this out on a calculator, but anytime you see something with times 10 to the 3, you just, or 10 to the anything, any exponent here, you just add the number of zeros that you see in the exponent. So 103 times 10 to the 3, you would write out the number 103 and add the exponent's worth of zeros. 1, 2, 3. And this works every time. Don't believe me? Go ahead and calculate it in your calculator and see what you end up getting. So 103 times 10 to the 3 in your calculator gives you 103,000. So let's try another example. 10 times 10 to the 5th. Well, we would write out the number 10 and then add 5 zeros. 1, 2, 3, 4, 5. So just a useful tip in case you encounter this. If we go 277 times 10 to the 2, that becomes 277, and then we add 2 zeros, 1, 2. So now we're going to get into percentages. Write each percent as a decimal. So 47%, in order to turn a percentage into a decimal, you would take the percent divided by 100. So whatever the percent is, divided by 100%. So 47%, we go 47 divided by 100, which gives us 0.47. Same thing with the 26.3. 26.3 divided by 100, we get 0.263. You can go ahead and pause the video and work through the next three in this column. All right, I'm just going to fix this here real quick. Okay, so that becomes 219 divided by 100. So that becomes 2.19. 0.02 times 100, or sorry, divided by 100. Let me actually do this in my calculator to make sure I have the correct number of zeros. So 0.0002 and 3.5. Write each decimal as a percent. So in order to take it from a decimal to a percent, you would just multiply by 100%. So 0.33 times 100% equals 33%. 0.04 times 100% equals 4%. 2.51 times 100% equals 251%. 6.8 times 100% equals 680%. 3 times 100% equals 300%. Percents problems. So what is 35% of 200? In order to solve this, you first have to convert the percent into a decimal, and then you multiply by the number they're asking you the percentage of. So 35% as a decimal is, divided by 100%, is 0.35. And then you would just multiply that by the 200 to give you 70. So 35% of 200 is 70. You can pause the video and work through the next one. Okay, 12.6%, we got to convert this to a decimal first. Divided by 100% is 0.126 times 192. 24.192. Okay, So 15% of what amount is 6? So now we're trying to find, we have 6. Now what was the bigger number that came from to get us 15%? So 6 is 15% of the whole. So how do we get to what the whole was? Well, in order to do this, we're going to have to do a little bit of algebra. And algebra uses x's as variables or x's as unknowns that we have to solve for. So in order to solve for this, we would convert this to a decimal divided by 100% to give us 0.15. So 0.15 times x, because we don't know what amount was the original, is equal to 6. So 0.15x is equal to 6. In order to solve for x, we have to isolate the variable. So we have to divide away this 0.15 on both sides. So that gets rid of that. And here we can divide here, 0.15. So 6 divided by 0.15 gives us 40. If 6 of the whole is 15% of the whole, then our whole has to be bigger than 6. So if you think about that logically, if we have 6 of something and 6 we're saying is 15% of the whole, and we're trying to figure out what the whole is, the whole has to be bigger than 6. When we look at this 40, we can easily go back and calculate if this is correct. We can go 6 divided by 40 to get the 0.15, and if we convert that to a percentage, we can see it's 15%. So go ahead and pause the video and work through this one. Okay, so we have 32% that we have to convert to a decimal divided by 100%, and we end up with 0.32. So 0.32 of what amount of x is equal to 55. So we need to solve for x. We need to isolate it. We got to get it by itself. So we're going to divide away the 0.32 on each side. Get rid of that and divide it over here. So 55 divided by 0.32 is equal to 171.875. 171.875. So 55 is 32% of 171,875. All right, so this is more like what you're going to see on the qualifying exam, and this is why knowing percentages is so important. Now, we are going to do some more of these application problems once we get to talking about solutions, but I do want to just go through this one with you so that you can understand the application. A 125 ml solution is 5.5% sodium chloride, volume to volume. The remaining content in the solution is water. How much water is in the solution? So first we convert this 5.5% to a decimal because we cannot work percentages with decimal numbers. So to convert this to a decimal, 5.5 divided by 100 equals 0.055. And I just double check that on my calculator. 5.5 divided by 100, 0.055. So 0.055 is talking about the sodium chloride portion. So in order to calculate what milliliter that is, we would do 0.055 times 125 mils. 0.055 times 125, we get 6.875 mils. So this is how many mils we have of the sodium chloride solution. But the remaining volume is water, and it's asking how much water is needed. So the total volume was 125 mils. 5% of that is the sodium chloride solution, and we just calculated that 5% of 125 is 6.875 mils. So to figure out the volume of water, when we subtract the two, we get 8.125. This looks kind of messy here. 118.125 mils of water.